So we're going to be talking about renal blood supply. Now, essentially, like every other organ in the body, the kidney is being perfused by an artery, a vessel known as renal artery. Okay. Now, let's start from saying that. Well, of course, as the blood is pumped by the heart, 22% of this volume of blood gets to the kidney. So we are looking around 1,100 millimeters per minute. Okay, that is sent to the kidney, not being filtered, but sent to the kidney. So now we want to look at how this renal artery, how the blood is supplied throughout the kidney. Now, of course, the renal artery, which is the main supply of the kidney, gets into through a space known as the helium. Okay, from there it branches forward. Now, I want to show you the parts of how this branching goes like. So now this of course is a diagram of blood supply to the kidney. Now we have first of all okay, this red guy here is the renal artery. Okay, this is the renal artery. This red vessel, red looking vessel, artery. Okay, we mostly say it's red because it's of course oxygenated. Now as it goes, it forms this segmentary artery, which is like the main guy that goes forward to branching. Before you might be asking what's a helium is. Helium is this space here, like in a bean. That's central seed. That's where the renal artery pass, just like in a bean. So this is the helium. Now as it goes, it branches into four basic arteries. Okay, now number one, you get the interlobar arteries. This is it. Interlobar arteries. Why is it called interlobar? It is present between two lobes. Interlobar. Anytime you hear interlobe, you know that is between. So it goes up to form the arc artery, known as the arcuate artery. Of course, it's called an arcuate because uh, it forms an arc. It looks like an arc. As it goes forwards again, forms another branch known as the interlobar artery. Being pointed there, of course. No, now interlobular. Sorry for that mistake. Now lobular means like a smaller form of a lobe. You get, so it's like in between two smaller forms of lobe. That's what interlobular means. So these are all the division. Finally, the boss, of course, the afferent arterioles. All right, arterioles. In this case, it gets though it has been expanded from here, all right, to here, as you can see. So this afferent arteriole is the guy that actually forms the glomerulus. Of course, you might heard of glomerulus, but we're going to touch that section maybe next time. So this glomerulus is like a fenestrated kind of capillary that's filters blood. But let's not go into details now. Let's just focus on renal blood supply. So as it gets to the Bowman capsule, it forms these tufts of capillaries known as the glomerulus. Okay. Now, at the distal terminal of this glomerulus, they come together. Coalesce. It's called coalesce. Let me just write it out here. Coalesce. They all coalesce. S-A. Coalesce to form an efferent arteriole. The guy that sends blood out to do the reabsorption and filtration in the nephron. Okay, we'll get to that. So of course there is another capillary waiting ahead of the afferent arteriole. It's known as the petubular capillary or vasa recta. So this guy is where reabsorption takes place. This guy is where filtration takes place. All right, so let's not get too much excited here. So this afferent arteriole, the main function it does is to let me give you a better diagram for us. Now this is the afferent arteriole. Of course, normally it's supposed to be from capillary to venule and venule, but in the kidney it's not so. All right, it's actually the second section of the capillary that goes out to form the renal vein. So afferent, anytime you hear afferent, it's outside, going towards outside. Afferent, inside. Okay, this is inside, this is outside. Like I said, this is where stuff occurs. Now going to the petubular capillary. All right. Now, like I said, the efferent arteriole is what helps to regulate the hydrostatic pressure between the two capillary pressure, of course. Now, when there is high hydrostatic pressure, about 55 millimeter mercury in the afferent arteriole, there is a very quick, filtration, fluid filtration. And when there is a low hydrostatic pressure in the petular capillaries, there is high reabsorption. I don't know whether you get the point. Now, of course, when blood, goes, then when there is a high flow of blood through this portion, it flows. Of course, you see, there'll be more filter. Just imagine, like, let's say a can of Coke, you just put a needle on top of it. All right, like open it through the hole, very tiny hole on the bottle. You shake it. You see that the Coke automatically, you know, releases the fluid because of the high pressure. So the high pressure causes high filtration. All right, so yeah, you get the point. So, but when there is a low movement here, as it goes, of course, in order to reabsorb more, when there is high, in order to reabsorb more, there has to be low speed. When everything is going fast, you hardly find time to grab what you want to grab. All of them keeps moving fast, so you can't. So that's why when there is a low hydrostatic pressure, of course, there is high reabsorption. So by adjusting the resistance of the afferent and efferent arterioles, the kidney can regulate the hydrostatic pressure in both the glomerulus and the petubular capillary, thereby changing the rate of glomerular filtration, tubular resorption, or both in response to body hemostatic demands. Okay, now the petubular capillaries empty into the vessels, all right, of the venous system. At this point, you get to form the renal vein. Of course, it progressively forms just like arterioles from the interlobar vein to the articulate vein to the interlobar vein and the renal vein finally, which leaves the kidney. Bye bye. So, guys, I hope you enjoyed this video. Hope you learned a lot from it too. So, see you next time. We are going to talk about glomerular filtration next time. You see. All right. And if you have any questions, just drop it on the comments. Thank you for watching.